We are going to today take a look at some specific examples of periodic functions and why we wanted to look at periodic functions in the first place, because we're going to look at our trig functions. And our trig functions are y equals sine theta, y equals cos theta, and y equals tan theta. And when we are graphing that, we're using our angles and our ratios to plot points on our grid. So you'll notice that theta can be measured in degrees or in radians. And again, when we're talking about angles in standard position, we can measure those in degrees or radians. And the ratios for those angles, as long as they are equivalent spots on our grid, are going to be the same. So the sine ratio for 45-degree angle or a pi over 4 is exactly the same. So we recognize that we can plot our theta axis in degrees or radians. Traditionally, we're going to choose one or the other. We are going to stick mostly to degrees right now to make it a little bit simpler. You'll talk about it in radians a whole lot more in grade 12. So what I have done here is simply punched into the calculator sine of 0. So subbing in our angles, and I've started down here just to take a look at the first full positive rotation or first full rotation for positive angles. So going counterclockwise from the x-axis. So sine of 0 is 0. Sine of 45 is 0.7 rounded to 1 decimal place. Sine of 90 is 1, and so forth. We'll notice that if we have all of these values, and you can put those into your calculator, when we go to 360, we've done one full rotation of our grid. Well, this is where our cycle starts again. So as we talked about yesterday, periodic functions, one full cycle is the period of the graph, and we're going to take a look at it graphically as well. But that means that 405 and 45 are coterminal angles, which means they're going to have the same sine ratio. 450 and 90 are going to have the same sine ratio, so we can use this pattern to go and look at our coterminal angles in our values. So back to 0, to negative 0.7, negative 1, negative 0.7, and back to 0. And again, notice that one full rotation, remember we talked about there are 4 places, one in each quadrant, that has the same numeric value of sine. In our first quadrant and our second quadrant, they are positive. And in our third quadrant and our fourth quadrant, they're negative. So that makes sense when we think about our cast rule as well and our angles in standard position, and then why that repeats for a second cycle. And that's also going to happen when we go to our negative angles. Remember, our negative angles just mean we're going clockwise from the x-axis on a grid, and that means that negative 4 pi is coterminal with 0, so it's also going to have a 0. Negative 675 is coterminal with 45, so they're going to have the same value. And this pattern is going to continue in our negative values as well. And we're going to keep doing that until we have all of our values. And then we're going to graph this function. Notice that our values for y, the largest we can have is 1, the smallest we can have is negative 1. And again, remember that makes sense because we said that hypotenuse cannot be greater than your opposite side. Hypotenuse is always going to be greater than your opposite side. It has to be. It's the largest side in your triangle. So we can never have a ratio greater than 1 or less than negative 1. So taking a look at graphing this, we're going to set up our grid. And we're going to obviously have y on our y-axis. Our x-axis in this case is theta. That's interchangeable. Theta or x can represent our angles, so it just comes from our function, whichever variable we're using. So we talked about our maximum value for y was 1, our minimum value for y was -1, which means that we only need to go to 1 and -1 on our axis. And that means we're going to use 0.5 for each mark on the vertical axis, which means we're going to go up to 1 and down to -1. And sorry I didn't center that very well, but you get the idea. And we are going to use a scale of 45 degrees for each mark on the horizontal axis. So we don't have to label every single one of them. We know 45, 90, 135, and 180. We're going to label every 180. So 4 blocks is 180, gives us 360, 540, and 720. And we're going to do the same thing with our negatives. Sorry, that should be -540. And you want to get really comfortable graphing these because we're going to be doing all of our transformations for these as well. So we started at 0. At 45 we had 0.7. '90 was 1, 0.7, down to 0. Down to -0.7, -1, -0.7, back to 0. So we notice that this is a nice smooth curve, and we can see what one cycle looks like. And again, that pattern is going to continue as we go along here. Now, again, that pattern is going to continue the other way if we go into the negatives. So we're going to start with -0.7, -1, and we can either use each point that we have on our table, or we can use the pattern that we discovered as well. And again, drawing our nice smooth curve. We have arrows on the ends because we know that pattern continues. And we have our graph of y equals sine theta. So, taking a look at some properties. We already talked about our max and our min values. Highest value we have for y is 1. Lowest value we have for y is -1. Our y-intercept happens at the origin, so our y-intercept is 0. Taking a look at our x-intercepts, our first one is 0. Then we have 180, 360. So we can see that it's happening every 180. So we can state that as n times 180. We just have to make sure that n is an integer. So we can't put in a half. We are talking about a full 180 every time that it comes back to 0. Our amplitude, remember our amplitude is our max minus our minimum. So 1 minus -1 divided by 2. So our amplitude is 1. And our amplitude is measured as half the height of our graph. When we take our max, subtract our min, we're finding the height of the whole graph. Dividing it by 2 means that it is from the middle of our graph 1 unit to the top or the bottom. And we talked about our full cycle, or the period of a cycle, is 360 degrees. 1 full rotation on our grid. Okay, so this is our graph of y equals sine theta. We also want to be able to graph y equals cos theta and y equals tan theta. So that's going to be your work for today, is do the same thing that we did for y equals sine theta. Use your calculator to find the cosine ratio. Use your calculator to find the tan ratio for each of those angles. And you can stick to degrees. You don't have to do both. Notice that the only difference would be how we scale theta. So we're going to stick to mainly degrees, and you're going to come up with those graphs. And if you want, use Desmos to help you figure that out.